So we'll be starting day 2 properly. So we'll start with data processing and understanding the business problem. So for understanding the business problem, I'll just like to show us what we'll be working with. We'll be working with a particular file. So from the data we filled online, from the forms we filled online, this is the form, the responses form. I think we opened that yesterday. I think it's on sheet 1. Okay, so now this is what the responses look like. So yesterday we tried to use this responses form to explain the descriptive statistics, where we're trying to measure mean, median, mode, range, and all of that. And I tried to work on the data, and I couldn't really find a reasonable correlation to work with. So we won't be moving forward with this data set. In order for us to understand better, we will be moving forward with this house pricing house price data set. So basically we have this information. We have the prices of different houses. I think these prices are in thousand US dollars, and we have the crime rates in that particular area. We have the residential area. I think this is in square feet. We have the air quality of that particular area. We have the numbers of room in that particular building we are trying to sell. We have the age of the house. We have the distance. So this distance are distance to like employment center, distance 1, 2, 3, and 4. We have numbers of teachers in that particular region. We have the poor proportion. We have the is for that area, is there like an airport close to that area or not? We have the numbers of hospital beds. We have the numbers of hotel room. We have rainfall. We have water body rather. We have rainfall. We have bus terminals, and we have parks. So these are different data. These are different variables we have, or different data we have about we have for our regression model we're trying to build. So now all of this data, right, from crime down to the sparks, they are called our these are our X, right? And remember yesterday we said X are the independent variables. So with all of these data sets, we are trying to predict the price of our house. So we have a particular house, or we have different houses with this data set. Now with all of these houses, we're trying to predict the price of the house. So now what we will do today is to try to predict the price of house using one or more of these data sets. So this particular data set has about 506 rows. So we'll explore the data set, and we'll try to work with it. So now with this data set, you can start even without working with it, right? Now we know our end goal is to predict the price, right? So now you can start formulating business knowledge around what we want to do. All right, so now we'll talk about exploratory data analysis. So exploratory data analysis is basically the process of understanding our data sets before we start looking for answers to our problem. Now the answer we are trying to look for in this particular problem is to predict the house pricing. We want to predict house prices, right? So that is our particular concern. We want to predict house pricing. But before we even build a model to predict the house prices, we want to understand what the data is, what is happening within the data set. Or is this data set actually useful for what I want to do? So it was when I was doing the exploratory data analysis for the data we filled online, then I realized I could not we couldn't use that particular form information, that is the trying to gauge the age and how people sleep. From the information we collected, we could not use that to build a model. So you have to just explore your data, and we'll do some stuff. We'll do that very soon in Python. So the main goal of the of EDA, which is exploratory data analysis, is to basically validate our data the data sets data. Now we're trying to validate those data inside our data. So that is like the aim. So we are doing this basically to determine whether the data makes sense in light of the problem at hand and to gain more understanding about the problem we are addressing. So the steps for EDA is descriptive statistics, which is what I was like trying to explain earlier. So yesterday we spoke about descriptive statistics. So we'll be trying to like describe the information in our data and see if it makes sense for what we want to build or not. Then the other thing is we have to like identify missing values, we have to identify outliers, and after identifying the outliers, we also treat the outliers. Then we do a correlation analysis, like see how how um how a particular variable affects how a particular independent variable affects the dependent variable, or how a particular independent variable affects another independent variable. So we try to like check our data, right? We try to see how does this data correlate with each other. If I increase x, will y increase? If I decrease y, if I decrease x, would y increase? So we'll try to do all of this correlation, and basically that is what EDA is about. Then the next thing is feature engineering. So feature engineering is basically trying to create new data sets, right? We're trying to create new data sets from the data we have. So basically that is what feature engineering is about. So for example, for this Excel now, here we have like distance 1, 2, 3, and 4. We basically don't need like it's quite redundant when we have like 4 distances, so we can like do feature engineering to this data set and actually just bring out one distance from the 4 distances we have. So that's about that. Then so the techniques we use in feature engineering, so there are different techniques we use in feature engineering. So the first one is imputation. So imputation is used when we are dealing with missing values. All right, so imputation is basically used when we are dealing with missing values, and it can impact our model. So we have different type of imputation. So we have the numerical imputation. Remember, we spoke about numeric data sets and categorical data sets. So you could have uh, numeric imputation for we could have imputation for numeric data sets and for categorical data sets. So probably when we are dealing with yes or no, and some people did not, maybe you give out a form and some people did not feel yes or no or something. So they use categorical imputation, and you just go with the highest value in the column. So that would be what you impute. And for numerical imputation, say we are dealing with for example, for our data sets we collected data sets about how people sleep, the average sleep time. So for that, if someone did not feel the amount of hours the person sleeps, so you could just take the mean of that particular distribution and you impute it. So that's about imputation. So another step we use in feature engineering is handling outliers. So when we have outliers in our data set, it basically displaces our data. So for example, just to illustrate what I'm trying to talk about. So yesterday we had some numbers. Okay, so now we had some numbers 1 to, so imagine 100 is not in our data set. We just have 1 to 20, right? So now if you take the mean of 1 to 20, let's just do that real quick. So let's just say mean average rather. So you say average, and you take all of these numbers, right? Take all of these numbers, you get 10, right? So now let's introduce an outlier. So if you introduce an outlier, and let's say the outlier is 100, all right. So if we introduce an outlier, right, now the outlier is 100. Now we want to take the mean again. So if we say if we say equals to again, and now we want to say average. So now we want to average everything, right? So we want to average everything. So look at this. The mean has been, sorry, let me just say I got it right. All right, so the mean has been affected. Also, if you want to like check for the range would also be affected. If you do for the standard deviation would also be affected. So the outliers in our data set, basically it really disturbs our data. So some people just remove the outliers, right? But removing the outlier is not actually the best way to go around the data sets, except you have like a very voluminous data set, so you can actually remove. You could actually replace the outliers as well. So wherever you have outliers that are actually beyond some particular range, you could actually replace them with the mean, you could replace them with the median, and depending on business knowledge, you could replace them with the mode. All right, so but for this class, we'll be dealing with capping and flooring. So there's a technique in feature engineering also called capping and flooring. So basically, um, when you have outliers, when you have outliers, it's a way to reduce the effect of the outlier. So if you have, for example, in our Excel, um, we had in this particular Excel, we have 1 1 to 20, then we have 100. Obviously this 100 is an outlier, right? So we can actually we can reduce uh the value of this 100. We can change it to something like 50, but we don't just change changes, we cap it. So we'll do that when we get to Python, and we'll see how we can actually cap and floor all of our outliers, so just reduce the effect of this particular outliers. So the other forms of feature engineering, we won't be talking about them, but you can explore them later on. Log transformation, one-hot encoding, scaling, and normalization. So basically, all of this is just to scale down the effect of large numbers. Let me just put it that way. So that about that. Then I found some interesting use cases of linear regression online. So I'll just copy this and paste it in the chat box in case you want to explore, in case you want to explore in case you want to explore linear regression, and you want to see like how you could also uh, use linear regression in your day-to-day activities or something. So I pasted the link, and that link is basically some interesting use cases I found regarding linear regression. Then if you want to also do further reading, you want to read more about linear regression, I also have some resources you could also go through to read about linear regression. So I'll just paste the resources here as well. So now we've been talking about everything so far theoretically, and now we'll just try to go to do this thing. We'll try to practicalize out everything. So we'll be using Python very soon now. All right, so we'll be using Anaconda. Basically, we'll be using Anaconda. So if you don't have Anaconda installed on your device, so what you want to do is to install Anaconda. In our previous session, we spoke about how to install Anaconda. So you can just go to our YouTube channel and you find the videos there. So you open this Anaconda navigator. Once you open the Anaconda navigator, then you open your Jupyter notebook. So once you open Jupyter notebook, you have this type of interface. So you have something similar to this. So I'll just go to the folder we want to work with. So we are working with okay, we're working with this particular folder. So you just click the folder opens up, and all right, so I'll open a new Python notebook. So this is what the interface looks like. We also explored how the interface looks like in our previous section. So you can always just go back and view our previous videos to just learn more about it. So now we want to start linear regression in Python. But before we do, I also want us to, so all of these steps we spoke about, all of the steps we spoke about in exploratory data analysis. I just want us to like to explore our data and see and build our model basically. So let's get started. All right. So before we get started, the very first thing to do is to import um, some libraries we'll be using, because we can't work without these libraries, right? So we have to import the libraries. So we start with the first keyword, so import. So now you want to import some libraries. These libraries are like very important to build our models, and that is what we'll be working with. So you have to import all of these libraries. So for our use case, we'll be importing pandas, we'll be importing numpy, we'll be importing Seaborn. So these are the libraries we'll be using. So if you want more information about Python, please go to our YouTube channel and watch this Python walkthrough. If you watch this Python walkthrough, you won't be naive to some of the stuff I'm saying, but I believe you have some fundamental knowledge about Python already. So I'll just continue. So we import our model, we import our libraries. So the first library we import is NumPy. So we import NumPy as NP. So we would also import pandas. So we want to import pandas as PD. So import pandas as PD, and finally we would import Seaborn. Import Seaborn. So Seaborn is a visualization library. So this is what we'll be using to like visualize all of our data. So we import Seaborn as SNS. So if you run this, so to run, I just press Shift and Enter and go to the next cell. So I prefer writing all of my import statements on a straight line like this. If you don't like this, you can actually you can keep repeating the imports. So something like this. So you just say import pandas again. Then you say something like this. Import Seaborn, but you have to remove all of these commas. You have to remove all of these commas. So if you do it this way, it works. It makes your code more readable. But I just prefer having my import statements in one line. So now the next thing is to check. I like checking my working directory, so I can grab my data immediately. So to check my working directory, so to check the working directory, use the keyword pwd. So once you use the keyword pwd, it takes us to the working directory, and now this is the working directory I'm working with. So from our working directory, we have all of these files in them. So I can like get any I can get any I can get any of this data. So I would want us to like see the responses and see what the responses looks like. So now if you want to read something into your data frame, you use we use pandas to do that. So I'll just call let me say this is data. So the data, and then I'm saving responses into this variable data. So we say data is equals to, now you call this pandas, right? So you say pd dot, now you say read. So now once we say pd read, we want to read our csv, we want to read it into pandas. So now I want to read this particular responses into pandas. So I'll just copy the name. So and I'll paste it back into into I'll paste it back here, and once we do this, that is all we need to do. We don't need to do any other additional we don't need to give it any other additional parameters. So if you read this, it basically reads. Now if you want to see the data, so you just say data, now you say dots add. So once you do this, it gives you the first 5 rows of the it gives you the first 5 rows of the data we have inside these responses. So let's just do that. So now you can see we have the first 5 rows. So this is the first person that registered, the second person, the third, fourth, and fifth, and you can see all of the data they gave. So if you want more rows, maybe you want just the first 2 rows, you can give a parameter into this place. You say 2. So I just don't want to bore us, because this is not our main focus. This response is not our main focus. I just want to tell us why why we are not going to use this particular data set. So now let's just do a little bit of plotting. So let's say sns dot join plot. So now we want to just plot what we need. So our x and y is the age and sleep. So let's just do that. So let's say x is equals to, now our x is the independent variable, right? So remember, we're trying to like judge how people sleep by their age. So we say age, so we give it age, and now say comma. Now what's our y? Our y is the sleep time. So the sleep, we have that here, and finally we are working with the data we are working with is this particular data. So we just say data is equals to data, and now if you run this, it should give you a plot. So now looking at this plot, right, I couldn't really place a correlation. Like it feels like it does not have this correlation we need and stuff like that. So to just make sure we like fully understand, so we can't really explore this data like so well. So for us to be able to like explore this data like for us to be able to explore this data just the way we want it, so I thought about we using this house pricing data set. So the house pricing data set is actually packed. I think you can just, if you google house pricing CSV for linear regression, you'd like you see this data set online. So instead of just working with this, so we'd work with the house pricing data set. So now let's just get started. So we say data frame. So I'm calling data frame df, just the short form. We say df is equals, so now we want to read the new data set we are working with. So we say data frame is equals to, so we use the same function again, pd.read. So now we are reading CSV, right? So if you're working with Jupyter Notebook, you could press the tab. So once you press the tab, it gives you suggestions you could like just use to complete um, everything you're working with. So now you could also use the shift and tab. If you press shift and tab, it gives you a little bit of information. It gives you a little bit of kindly mute David, kindly mute David, kindly mute. Hello David, kindly mute. Yeah, thank you very much. So where were we? All right. So it gives you, if you press shift and tab, it gives you a little bit of information about what you want to work with. So the first parameter is the parts. So you could actually input the parts. The second parameter is the separator. We have delimiter, we have header, we have all of this. So if you want to read more about it, you could actually go to the docs, or you could just press this. If you press this shift and tab 3 times, it would open a bigger tab for you, and you could just scroll down and you read every information about it. So I don't want to like go into details of that. I just want us to like get started immediately. So now we would give it the very first parameter. So the very first parameter is our housing data set. So now this is what we want to give it. So now we just run this. So now this is our data frame. Now our data frame is storing this housing data set, right? So now we want to see um the data in our data frame. So you just say data frame dot head. So now if you see data frame dot head, it returns the first 5 rows. So now you can see all of the data sets in our, you can see the first 5 rows in our data set. So this is the crime, this is the price of the houses, this is the crime rates, this is the residential area, this is the air quality, and all of this information. We have all of this information in our data set. So now we want to start with I spoke about exploratory data analysis, and these are the steps in exploratory data analysis. So the very first step is descriptive statistics. So descriptive statistics is trying to like describe our data, right? So now let's start describing the data. So to do EDA, so the first thing is to describe our data. Now to describe our data, we can first start with what is the shape of this data. So the shape of this data is like the data we are working with, how many rows does it have, how many columns does it have. So we say df.shape. So once you say df.shape, you hit shift enter. So now it returns the numbers of rows, and let me just comment on this. So um, if you are watching this later, you would understand. So this is to return rows and columns. So now once we say df.shape, it returns the rows and columns to us. So now we have the idea that this data set we are working with, it has 506 rows and 19 columns. So if you count all of these columns one after the other, 1, 2, 3, 4, then to the last one, you get 19 columns. So that is an handful of data sets, and now we have 506 rows. So now the next thing we want to do, still on the descriptive statistics. Remember, the first step in our EDA is to describe the data. So now we know the shape of our data set. So now the next thing we want to do is to actually describe the data. So now you say data frame dot. Now there's a function called describe function. So you use the describe function. So now once you press data frame dot describe, so you want to give it some brackets, open and close it. So now once you do this, now you get the descriptive statistic of our data frame. This is everything. This basically gives a full account. It describes our data to us. So now the first thing you want to look at is the counts, right? So the counts means how many variables do you have in each column. So now for the price column, we have 506. So this is actually very correct. So now if you just inspect, so let us just inspect the counts of every item, of every column. So now if you look at the numbers of hospital beds, we can see this has some missing values. So now, even this way, we've been able to identify missing values just describing our data. Every other column has 506, except the numbers of hospital beds. So describing our data is very important. We've not even started we've not built our model, we've not done anything. We've been able to identify some missing values. So now, not just that, you can also identify outliers. But how do we identify outliers? So you want to look at every item. You want to look at the mean, you want to look at the standard deviation, you want to look at the minimum value, you want to look at the maximum value. This 50% is the median. This is the 50 percentile value. So this is the quartile value. That's the 25 percentile, and this is the 75 percentile. So you want to look at all these values. Now, if you look at all these values, you can study them and identify if there's something wrong. So the first way to identify if there's something wrong with your data set is to compare the mean the mean value and the median value. So if you look at the mean and the median, you'll be able to identify outliers, right? You'll be able to know something is wrong with your data set, because ideally the mean and the median should be close, right? So you just want to inspect, look at this is the mean and this is the median. They are relatively close. So you want to look at all of this, mean and median, they are relatively close. You want to look at every value. So anywhere you see the mean and median are far apart, then that value, that particular data set is either skewed to the right or skewed to the left. So yesterday we spoke about skewness. We spoke about skewness when we were trying to relate mean, median, and mode somewhere here. So when we're trying to relate mean, median, and mode, so we spoke about skewness. So now, just going back to this particular data. So another way to validate if there are outliers in our data set is to compare the minimum value, right, to the 25 percentile value, and also to compare the 75 percentile value to the maximum value. So let us just compare the 75 percentile value to the maximum value. So if you look at all right, good. Look at this, the number of hotel rooms, right? I just want to admit this person. All right, so if you look at the numbers of hotel rooms, you can see the 75 percentile is 14, and now the maximum value is 101. So this is definitely an outlier. Like it is so obvious that an outlier is there. Like we can be so sure that yes, in this data set there's an outlier. So just looking at describing our data, we can get a lot of information. We can be able to analyze our data. We can say we can give more we can get more details about our data. Just to explain what the percentile means. So now this 25 percentile value is 17, and it's trying to say this is like the quartile value. Like if you divide the values in ascending order, this is the value at the 25% position, at the quartile position rather, and every other value below it, say from 0 to the quartile value, is actually less than this particular figure. So now going back to this, you'd see that something is definitely wrong when this is 100, this is 101, and the 75 percentile is just 14. So definitely there's an outlier. So if you look at the mean and the median as well, you'd see it is probably not close together. So another way to also check for our data set is to check the information about our data set. So you use dataframe.info. So use dataframe.info to do that. So when you do dataframe.info, it tells you how many rows you have and all of that. So you can see we have 506 rows. Now look at all of these rows. Now, okay, so for this describe function, right? This describe is only telling us about the numerical data sets, right? It's only concerned about numerical data. Like if you look at this, we won't see. So this is our data frame. This is all of the values in our data frame. So look at this: the airport yes, airport no, and so this airport yes, airport no are categorical data sets. We cannot assign numbers to them. Remember from our training yesterday, the river, the water body as well, having river, lake, non-river, lake, and all of that. These are categorical data sets. So when you use the describe function, the describe does not give you information about categorical data. It only gives you information about numeric. If you look at this, every data here, everything we have here are basically numeric data. We don't have categorical data here. But this is where the info comes useful and it comes in handy. The info basically gives us information about everything in our data frame, be it categorical, be it numerical. So anywhere you see object, you just know that this object is trying to signify categorical data sets. The data set there is actually categorical. So we have one object here. This airport, you also have objects. It's saying it's categorical. This finally, this bus terminal is also saying object. So others are floats. So we know floating numbers and numbers with decimal points, and those are like the continuous data. And now this integers, okay, in 64, this is basically integer. Let's say the column for rainfall. Okay, so the values are basically integers, like they are basically whole numbers. So I think that's why it has that as integers. So if you look at this as well, every 10 years I've been 506, 506, 506, except the numbers of hospital beds. So now the numbers of hospital beds is 496. So we have about 8 missing values. So going back to our EDA file. So now with describing our data, right? So this is we spoke about EDA if you're just joining, and these are the steps we are trying to like outline in our EDA. So the very first step is the descriptive statistics, which is what we've done with the describe and info and using the shape to know how the data set looks like. Now when we did this, we could actually identify missing values. Just describing, right? We could identify missing values. Also, we also identified outliers. So just with this alone, we've been able to understand what our data set looks like. We have a sense of what our data set looks like. So the next thing to do is to just visualize all of this, because all of these things are basically like assumptions. So we said there's an outlier. We said there's a possibility, looking at this data set, we said there's this possibility of an outlier being in this numbers of hospital rooms, because the 75% value is 14 and the maximum value is 100. So this is basically looking like an outlier. So we just want to like confirm if there's an outlier in our data set. So let us just plot. So once we plot, we'll be plotting with Seaborn, and once we plot with Seaborn, we would have we'll be able to visualize if our information we use is just correct or not. So let's just do that. So let's just label this with Seaborn. So we're basically using Seaborn to like visualize the relationship between our independent variable and the dependent variable, and to see if there's any relationship or anything basically. For example, we used Seaborn earlier when we were working with these responses, and using Seaborn we saw we could not really create a form of correlation between our x and y. Yeah, So now let us just use Seaborn further to for this new data set we are working with. So the first thing we want to work on is the number of number of hotel rooms, this particular column. Let me just copy it. Remember, this is where we suspected an outlier would be. So let's say SNS. So we are using joint plots. So you say SNS your joint plot. And now if you press the shift and tab, if you press it 3 times or twice, it gives you this information, and now you can like check it and you can like see all the data sets it requires. So we'll just be going with X, Y, and going with our data sets. The default type of plot is the scatter plot. So let's just do that. So we would say X. Now our X is, so the X is the independent variable. Do not forget that. So now X is what we want to inspect, and that is the number of number of hotel rooms. Then the next thing is Y. So what is our Y? Our Y is the dependent variable, which is the price. Remember, we're trying to predict price based on the numbers of hotel rooms, or we are trying to predict price with any of these columns. We have here crime rates, residential area, and all of this. So now the last value we want to work with is our data. So now what data are we working with? The data we are working with is the data frame, which is what we declared earlier, here with our pandas. So now if you run this, you get a scatter plot. So now looking at this, we can see we've identified outliers. So when we use the describe function here, we just suspected that there might be an outlier here because this is 14, the 75 percentile is 14, and the maximum value is like 101. So now when we plotted it, we can actually see, oh, we actually have outliers. So we use Seaborn to plot, and when you use Seaborn to plot, we could actually identify 2 different outliers here. So let us also plot other columns. So let's say SNS again. So let me just copy this instead of typing all over again. So I'll just copy this and I'll paste it here. So now the column, let's just inspect another column. So the column we want to inspect now is the rainfall. I think the rainfall also have some outliers. So we have a rainfall column. Let's go back to the descriptive statistics. So if you look at this particular rainfall column, if you look at this is the minimum price. This is the minimum. So let us just check the minimum and the 25th percentile rainfall. So the minimum is 3 and the 25th percentile is 28. So it's also looking like there's an outlier in this particular column. So let us just plot that as well. So if we plot it, we'll be able to visualize the outlier. So now looking at this, we can see there's actually an outlier here in our data set. All of our data set is clustered from like 2 to 60. I'm just have one value independently staying here. I have to admit one more person to the call. So now we can actually visualize this outlier. So we are actually very certain that, oh, there's an outlier in our data set. So far we've seen the descriptive statistics. From the descriptive statistics, we're able to suspect outliers, and now we've been able to identify these outliers where they are in our data set. And also with the descriptive statistics, we've also been able to like identify which column has the missing value. So we'll just continue. So we've been able to visualize all of this. And now when all of these are visualizations we've been doing so far, we've been visualizing numeric data, right? So we've been visualizing numbers and stuff like that. So now, but for example, we have some of our data sets in our data frame that are not numeric. For example, airports, water body, these are not numeric data sets, they are categorical data sets. So if you want to visualize them with Seaborn, how do we visualize them? So so far we've been using the joint plots to visualize and identify the outliers. So now if you want to visualize, let me just label this. So visualizing categorical variables. So now we want to visualize categorical variables. So to visualize categorical variables, we use the count plot. So SNS as count plot. So we have SNS.count plot. Now if you use the SNS.count plot, you just give it one particular variable. You don't give it X and Y like we're given this, because we just want to check just for one variable. So we can say X is equals to, now we want to check for the let's see. Okay, so we can check for the airport, since this is a categorical variable. So I'll just say airport. So now I'll just paste airport inside the variable of X, and now we have to give it the data we want to work with. So now the data is the data frame. So now if you plot this, now you see where you see how many places as reported yes for airports, about maybe 300, and we have places with no for airports. So let me just copy this again, and we do this for another independent variable. So another categorical variable, I think that's water body. Water body is also showing us yeah. So let us just copy this, and we'll just check for water body as well. So I'll just paste it here, and if you run this, you can see the count for places with rivers, lakes, where there are no water body at all, and lakes, rivers and lakes. So if it changes X to Y, it just changes the position of the plot. So let me just do that. So you see it just changes the position of the plot. So we've spoken about all of this. Now the next thing we want to talk about is treating outliers, right? So we've identified outliers previously in our data set. So let us treat this let's treat this outliers, right? Let us treat this outliers. So let me label this as outliers treatment. So we want to treat outliers. So to treat outliers, we use capping. So when I was explaining the feature engineering on how to treat outliers, we spoke about capping. We spoke about capping. So this is what capping means. So capping is using an arbitrary value or value from a variable distribution to replace the maximum and the minimum values. So basically, that is what capping is. So now let us just implement it. So to treat outliers, we use two techniques, which are capping and flooring. So capping and flooring. So let me just tell us the steps involved. So to do this, so what we want to do, the very first thing we want to do is we want to find all values, right? We want to find all values. We want to find all values up above the 99th percentile, right? Just let me instead of typing, let me just implement it. Let me just implement it, right? So we'll do capping and flooring. So remember when we did the descriptive statistics for this number of hotel rooms, we realized there's an outlier when the maximum value, this is the 100 percentile, this is what it gave us, and this is the 75 percentile. So now we want to check the 99 percentile. What is the 99 percentile saying, right? So we want to check the value of the 99 percentile. So the value of the 99 percentile will give us an idea on how to like reduce this particular value, and also we'll do the same thing for this rainfall. So now let us when we plotted the number of hotel rooms, we can see we have these two as outliers. This is 80 and this is 100. So let us just cap and floor them. So the very first step is so I'll just comment find all values above the 99 percentile. So after we do that, after we find all values above the 99 percentile, then we do some math. So let's just find all the values above the 99 percentile. So the first thing is to get the 99 percentile value. So to get the 99 percentile value, NumPy makes it very easy. Remember, we did this. We imported NumPy from the very onset. So now we'll be using NumPy now. So what we want to do is to say, so there's a function, right? There's a function called percentile with NumPy. So you say there's a method rather. So you say mp.percentile. So now we want to get the 99 percentile of our data frame of the numbers of. So now we are dealing with this particular data, this particular column, the number of hotel rooms. Now we want to get the 99 percentile value of this particular column. So to do that, we say our data frame. Now the numbers of that the column we're interested in. Now we have a comma, then we have 99. So if we do this, if you run this, it basically returns the 99 percentile value. So now imagine this is the 99 percentile value, and the 100 percentile was giving us I think 101. So definitely an outlier, So we want to save. Now this is giving us an array, right? And in Python, to get the first value of an array, we just have to get the very first value of an array, you just call this, you just put it in brackets, and you put 0 in Python starts counting from 0. That's why we have 0. So it would just give us the very first value in the array. So now if you don't understand what I'm saying, please just go back to our YouTube channel and watch our YouTube videos. We've spoken about slicing and indexing previously on our YouTube channel, so you would understand everything. So now we'll save this particular value into upper limit, right? So we would save this particular value into upper limit. So for upper limit, I'm using UL. So we are saving this as the upper limit. So I'll just run this cell again. So this is the upper limit. So now we want to get the next step is to get. So the next step in copying is to get every value that are actually above the upper limit. So get all values above the upper limit. So we are trying to identify and treat the outliers. We've identified it previously, but now we want to identify and treat them again. So we want to get all values that are above the upper limit we've set. So now to do that, we just say the data frame. Now, what do we want to do to the data frame? We want to get all values. So you say, you give it a bracket. Now you say data frame. Now our particular column we are interested in. Now we want to say anywhere the data frame has values greater than UL. UL is our upper limit. It should just return it. So now if you look at this, this is our data frame with values greater than UL. So now if you go to the number of hotel rooms, this is number of hotel rooms. This particular column is number of hotel rooms. So now you see everything is within 15. Remember our let me just return our upper limit, right? Remember our upper limit is 15.39, almost 15.4, right? So now if you look at this again, you see all of these values, right? All of these values are between 15.4, 15.4, 15.4. Now it is just this particular value and this particular value that are greater than our upper limit. So it is so certain that these are the two outliers in our data. We've identified them. So look at this. If you look at this plot, remember we plotted this earlier. So these are the two values. Sorry, I just need to admit someone. Okay, I don't have a request anymore. All right, so these are the two values. So these are the two values we need to cap. These are the two values we need to cap. So looking at that, let me just scroll down. So now look at that. These are those values. So we need to cap these two values. We need to bring these two values down. So normally, remember when we spoke about how to handle outliers, you could actually remove them, right? You could remove them. You could replace them. I could replace this. I could replace this with the mean of that particular column. You could do anything. But I said, for this particular tutorial, we'll be capping them. So capping is just a way to like reduce the effect of the outliers, bring the outliers down, because they might probably be valid numbers, right? But people just like when the survey was taken or something, people just made a mistake and actually have like very higher values. So let us just cap them. So the next step is to cap. So let's cap. And there's a capping the outliers. So to cap the outliers, so what you want to do now is to select that particular column. So now to select the particular column, you call the column. So now we say data frame dots. Now this particular column. Now what do we want to do to those columns? So we want to say something like wherever, let me just copy this. So now we are saying wherever this data frame is greater than this limit we've given to it. So we want it to do something to 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 that data frame. So wherever the data frame is greater than let's say 3u. All right. So in order to preserve these values, remember these are like values from the data frame. We don't want to tamper with these values, right? So we now want to say wherever this particular value, right? Wherever this value we've gotten is greater than, so we multiplied this lower limit by 3. Let me just show you that in my calculator. So let's say 3 multiplied by 15.39952. So now wherever this function is going to look through our data frame, and it's going to look at this particular column, and it's going to look at this column wherever these values in this column is greater than 46, then we want to cap them. So capping, like I said, is reducing the effect of those outliers, right? So we want to do something. So now we can say we can equate it to, we can equate it to the mean of this particular, when I was talking about, I said we could actually remove them, we can replace them with a particular value, but now we want to cap them. So we don't want to remove them, we don't want to replace them with the mean, we want to cap them. So capping is just reducing the effect, right? So I want to reduce the effect to 3 multiplied I want to reduce the effect to 46. So wherever we have numbers that are actually, wherever we have outliers, I want to make the outliers to be 46. So we'll just say 3 multiplied by the upper limit. So now if you run this, so this is just giving a warning, it is not an error. So let's just copy this again and print it. So now if you copy this again and we run this, now if you look at the number of hotel rooms again, now you look at this, you see it is actually reduced. Now if you look at the outliers, so the outliers before, the outlier here was 80, 81, here was 100. So now we've reduced the effects of the outliers from 81 and 100 to 46. So that is how we cap in that's how we cap our outlier. So the next thing to do is flooring, but I'll just probably give you that to work on your own. So if you want to floor, so what you want to do is you want to change this. You want to first look for the values above. Remember we found outliers in our number from our descriptive statistics. We found outliers in our number of hotel rooms and number of and in the rainfall. So now this rainfall, the lower limit is what is actually is what has outliers, right? So you want to like reduce the effect of the outliers in the lower limits, and here we have the outliers around the upper limit. So that is why we cap, and one for the lower limit you floor. So if you want to do that, what you have to do is to just change anywhere you see this data frame, this column, right? This column. So you want to replace it with rainfall, and instead of greater than, remember it's lower limit, so you want to change it to less than. So that is how you cap and floor in Python. Just to preserve our time, I don't want to go into flooring. So now the next thing we want to talk about is missing value imputation. So remember we from the EDA steps, we spoke about descriptive, missing values, and outliers. So we've treated these outliers, and we've identified and treated them. So the next thing is the missing value imputation. So we want like impute all of these missing values, and from the future engineering, we spoke about all of these techniques to work with the missing value. So we'll see in a bit how we can work with this missing value. So now when we do data frame dot info like we did earlier, we could get all of the information about our data frame. And when we did that, we realized that we have missing values in the numbers of hospital beds. So we have everything normally, ideally, is meant to be 506, but for some reasons, this is 498. So it means we have 8 columns, 8 rows are missing. So now to fill this gap, let me just show you what the data frame looks like again. You can see data frame.add. So it gives the first 5 rows. So now in this particular row, the numbers of hospital beds, this particular row, it has some missing value. So now what we want to do is to like compute this missing value. So to compute this missing value, now we can use the mean, like the mean of this particular column to get the missing values, to input for the missing value. So there's a very simple way to do that, and that is using there's a function that is fill na. So fill na basically helps us to like input missing value. So what you want to do is you want to select that particular column, right? The very first thing to say, that particular column with the missing values, which is this. Let me just copy it. So now what do we want to do to that data frame with the missing values? So we want to fill. So the function is, so you call the colon, which is what we've done here. So now you use the function fill na. So fill na basically it fills your data frame with whatever you want to fill with it. Perhaps you want to fill it with mean, you want to fill it with median, or you want to fill it with mode. So now you just say data frame dot. Now you select that particular column again. Now you use the mean. So you say mean. So now we are filling anywhere there's missing values, right? Anywhere there's missing values in this particular column, we are in this particular column rather, we are filling it with the mean. That's the average number of the values in this particular column. So that is what this particular function is going to do. So now once we run this, and now let us run the info again. Remember here we had missing values in the info. So now if you run the information about the data frame again, so let's go to the now you see it has already filled it up with the main. So there are no missing values again. So we've treated all of our missing values. We've treated all of the missing values we have. So from the future engineering, we also spoke about okay, I think we've touched about everything here, but there's one more thing I want us to talk about, which is what I was explaining to us when I was showing you the Excel. So we have distance 1, 2, 3, and 4. We basically do not need all of these 4 distances, so we can just take the average of these 4 distances, turn it to one column, turn it to like an additional column in our data frame, and we delete all of these other 4 distances. So to do that, that is actually called variable transformation. So let me just call it variable transformation. All right. So to do variable transformation, we just to create a new column on our data frame, we call the data frame name, which is df, and now we open square brackets and we just give it the name. So let's say average distance. So we want to say average distance is equals to all of this. The average distance will be the addition of these 3 distances divided by 4. So to do that, we'll just open a bracket. So we say data frame dots. Now the first thing is the distance 1. Remember we have distance 1. So now we want to add that again to distance 2. So you can always press tab. So once you press tab, it gives you like an autocomplete. So you just like autocomplete what you need. So the next thing is data frame dot distance 3. So distance 3, and lastly data frame dot distance 4. So now we want to divide all of this by 4. So now if I run the data frame dot add, remember this returns the first 5 rows. So now you would see this average distance has already been added to our data frame. So now what we need to do is just delete distance 1, 2, 3, and 4, because like we don't need them again. We just work with the average distance. So to delete that, you just say you call delete, and once you call delete, then you call the colon you want to delete. So we want to delete distance 1. So we also want to do this. Let me just copy this because we want to do this for all of the 4 distances. Let me copy this again. I didn't put the distance in colon there. So you want to do this for distance 2. You want to do this again for distance 3, and finally you also want to do this for distance 4. So if I run this now, it will have deleted all of the distance. So if I run this particular um line 30 again, you see all of this distance would have been deleted. So let me just run that. So you see we don't have distance 1, 2, 3, and 4 anymore. So finally, yesterday when we were speaking about categorical variables, I was telling you that when we're talking about satisfaction, I said there's a way you could actually still work with categorical variables. You could actually assign numbers to them. For example, this airport, right? Airport, yes, no, yes, no. It would actually influence the price of the house, right? Uh, or let me assume it might influence the price of the house. But our Python, right? Python does not understand these categorical variables. Yes, no, yes, no, yes, no. So we have to turn them into numeric variables, right? We have to turn them into numeric variables. So to turn them into numeric variables, there's something called dummy variables. So we can create dummy variables, right? And to do that, it is pretty easy to create dummy variables. What's the shortcut you're using? I'm using tab. So if you want to like autocomplete anything, you can just use the tab. So the tab just like helps you with the autocomplete. So now to create dummy variables, right? You just need to use a pandas function and it creates a dummy variable. But the downside of the dummy variable is that it over creates the dummy variable, and at the end of the day we have to delete one of the variables it creates. So let us just do that. So now we want to create dummy variables for our data frame. So we call the data frame and we say our data frame is equal to pandas dot. Now there's a function in pandas called or method called get dummies. So you see when I press G, I press tab. Now it automatically uh, gives me what I want. So you say enter. So I want to get dummies for our data frame. So you just say this and you run this. So now once you run this, it automatically gets you the dummy variables for our data frames. Now if you want to see the dummy variables, so anywhere we have all of these categorical variables, it would create. So anywhere it says yes, it will give it 1. Anywhere it says no, it will give it 0. It will create a dummy variable to it. So now look at this now. Okay, now I didn't use the add function. So let me just say data frame.add. So it just gives us a neater result. So now you see it has reduced it. So the add basically returns the first 5 row, and if you do not give it the add function, it just returns your data frame to you and it reduces it. So now if you look at this, we have airports, no, where airports is where there are no airports, you can see them now. Where there are airports, so yes, it's saying there's airports here. 1 means there's airports, 0 means there's no airport. But for 0, for airports, no, you can also see the value. So we can now this is actually redundant. Instead of having 2 columns, right, we can delete airports no, or we can delete airports yes. So if we delete airports no, now all of these 0 values, right, all of these 0 values is actually airport no. So we don't actually need this column. The same thing for the water bodies, right? We have water body lake, water body river, water body none, and all of this. So we delete one of the dummy variable. So the rule of thumb dummy variable is that you delete one of the columns to reduce redundancy. So to do that, we would say all right, so we'll just delete one. So let us delete this airport no. So you just say delete, then you say data frame. Now you say the airport no. Let me just copy this. I really don't want to type it. So just say copy and paste it here. So now if I run this, it deletes that. So also for the water bodies, so we have water body lake, we have water body lake and river, we have water body none, we have water body river, and so we'll delete one of this. So we can delete water body none. So if we delete water body none, where water body lake, water body lake and river, and water body river is 0. So if you have any column for everything being 0, then that means water body none is actually 0. So we just delete water body none. So it basically makes our model more efficient that way. So we just say delete, say data frame, and finally water body none. So we delete that, and now our model is almost ready, almost ready, almost ready. So we've covered every of these steps. We've covered 1, 2, 3, and now the final thing is correlation. So like I explained during our theory lecture earlier in this call, so I said correlation is basically a statistical measure, right, that indicates the extent to which two or more variables fluctuate together. So the correlation is trying to check if I increase A would B increase, if I reduce A would B also reduce. So you're trying to like check the correlation of each of these properties or of these variables together. So let us just do that real quick. So to do that, we just say, let me just call this correlation. All right, so now we just call a simple function, say data frame dot correl, and now once you do this, you'd see the correlation of every item together. So now I'm glad I'm seeing this. We have this bus terminal as yes, and I think we would have to delete this particular bus terminal. So if you look at this bus terminal colon, everything is 1. It doesn't have any no. So everything is 1. So it won't affect our model. It has no way of affecting our model because everything is just 1 and there's no. So I'll just create a new column down. To create a new column down, you come outside and you press B. So it creates a new column, and now it creates a new line for you to write your code rather. And now I'll just copy this post terminal, yes, because but before we do that, let us just do a quick plot. We plotted some values here, right? All right, so let us just change this to bus terminal, right? Just to confirm everything is actually yes. So if you look at this, there's no. Bus terminal does not have any value with no. So we'll just delete. We delete. Oh shit. This is returning error because we already deleted a particular column. So let me just leave it as bus terminal. And now, since all the values in bus terminals are yes, it would not affect our model. So now I'll just delete that particular column, and that is why you see it's giving us not available here and for the correlation and stuff like that, and the fact that it is also a categorical variable. So we'll just delete that, and now we'll run our correlation again. So now you see it's not there anymore. So now our independent variables, we have all of them here, crime rates and all of that. Now the dependent variable is right, is price, right? So you want to check how all of this independent variable correlates with the independent variable. So now you want to check how this dependent variable of price correlates with every other values. Now, one thing to note is that for correlation, any value that tends to 1 has high correlation. Any value that tends to 1, it has very high correlation. And any value that tends to 0 does not have correlation. So all these values are very close to 0, like this water lake. It does not really impact our model. It doesn't affect our model. So imagine you have a lot of columns. Here we have just 19 columns, right? So imagine where you have just maybe 500 columns. To make the work easier for your model, you can start like from this correlation analysis, you can start deleting columns that are not useful to your model. So now anywhere you have values close to 1, that means that variable is highly correlated, like it is highly or mathematically you say positive correlated. It is positively correlated. And anywhere you have your values tending to -1, and it is also highly correlated, but it is negatively correlated. So now you want to look at this price column, and you want to look at all of these other um, independent variable. Now you want to look at which of these actually has high impact on our model. If you run this, so look at this, we have room number as 0.67. This is actually really good. I mean, it is very correlated with our price. You look at it again, you look, teachers is also somewhat highly correlated. Look at this, poor proportion is also correlated, but it is negatively correlated. So that means if poor proportion is going up, our price should be coming down. So you just look at all of this. Then aside looking at all of this, you also look at all of these independent variables, like all of these independent variables. You look at their correlation with each other too. So where you have multiple independent variables being correlated with each other, then you say there's this word to it, collinearity. So let's look for one. I think there should be one in this data set. I mean, it takes a lot of patience. You have to like look through all of this. Then each column to itself, right? If you look at price to price, it is always one. If you look at crime rates to crime rates, it is always one. So along the diagonal, you would have each value its correlation with itself, and each value correlation with itself is always one. It's always one. So I'm looking for cases of multicollinearity, and at the moment I cannot find one. But if you look through this data set, there should be one. So if you find a particular value that is actually highly correlated with like another independent variable, so you have to delete that to actually reduce the effect of multicollinearity in your model. So that is that about that, and let us just go ahead and build our machine learning model. So now we started this probably an hour ago. We started like Python probably an hour ago. So now building your model takes maybe 5 minutes, but the process of identifying outliers, cleaning your model, looking for like this EDA and feature engineering, basically it takes all of your time when you're building your model. It takes all of the time, but to build the model basically takes maybe a minute itself. It is very fast. So let us actually just go ahead and build our model. So now remember we are doing simple linear regression, and yesterday when we spoke about simple linear regression is just using one independent variable and one dependent variable, right? So that is what we'll be doing. So let's start our simple linear regression. So in short, people just call it regression, but for this class, let us just leave it as simple linear regression. All right. So now, there are two methods to it, right? There are two ways for us to build our linear model. The very first way to build our linear model is using the start model API, or using sklearn. Sklearn is the popular model we all know. Like, it's very popular, it's commonplace. So I'll teach you how to use the two model real quick. So now let's start using so the first one we're using is we're using the start model. So now what you want to do is to import start model. So you want to import start model. So you say import start model.api. So you import it as SN. So you run this. So now after that's run, after that run, now remember the formula to build our model is y is equals to beta naught plus beta 1x. Now for the start model, it doesn't have this beta naught. So we have to impute the beta naught as a constant. You have to add it as a constant. So to do that, we add constant. So we say sorry, it doesn't have this beta one, rather. So we have to add this beta one as a constant to our x. So now we have to do that. So to do that, we say our independent variable, which is x. Now it is always capitalized. x will now be equals to, now you say Sn dot add. So now you want to add those constants. So you say add constants. Now when we're looking at this correlation, right? We're looking at the correlation. Now look at the price and the room number, right? The price and the room number has a very, very high correlation here. So this is what would be what we'll be using as for a simple linear regression, this room number. So we are trying to check what happens when price change. Once the room number, the numbers of room change, what would happen to the price? So basically, these prices are dependent variable, and the room number is our independent variable for a simple linear regression. So let me just copy this room number, and it will be what we'll be using as our x. So now you say data frame. Now you have to input the room number. Now this is our x, right? So we've added the constants and we've created our x. So that is our x. Now the next thing is our y. So our y is basically data frame and the price. So you just say data frame and price. So that is the column we're interested in our y. So if you run this, that's our y. So the next thing we need to do is to call our model object and fit it. So now we say linear model. So I'm representing linear model as LM, which is what we are working with. So we say LM is equals to, now this Sn we've been working with, the start model we've been working with so far. So we say Sn dot. Now remember when we were talking about this yesterday, we said we're using ordinary least square method, and ordinary least square is OLS. So we just call that ordinary least square method, right? So we say OLS, and now when we say OLS, we call, this is the object, right? So we want to give it our x and y to train for us, right? So we say y comma x. So once you do that, the next thing you want to do is to like fit. You want to fit this model, right? So you say fit, and once you say fit, you just run this, and that is all. That is all. We've run our first, I can even say congratulations to you now, because we've run our first simple linear model. This is all we do. So imagine all of this work we've been doing so far just to write just 1, 2, 3, 4 lines of code. So building the model is very fast and it's very easy. What you want to do is to just understand the concept before you build the model, identify the outliers, clean your data, and do all of that. So now we can call the summary function to get the summary about our model. So now I'll just do that, and once we run this, now you get the summary of our model. Now yesterday we spoke about how to assess the accuracy of our model. So to assess the accuracy of our model, we said assess the accuracy, the predicted coefficients, the p-value should be 0.1, and the r squared, the closer it is to 0, that means our model is accurate. So now for the r square here, we have 0.448. It is not bad, because we are just doing simple linear regression. We are predicting with just one independent variable. When we use multiple variables, and that's when we use like when we use all of these other data sets we have to predict price, then this our r square would actually increase. But now we are just using just one variable, so this r square score is not so bad. Then also now we said we have two values, right? We have let me just go back to the equation. So we have this beta naught as the intercept, and we have the beta 1 as our gradient. Now so this is it. So now this constant minus 34 is our beta naught, and this is our beta 1. So if you want to create an equation for this particular line, so the equation would be something like y will be equals to say 0.0997 multiplied by your room number minus 34. So this will give you the actual equation to get any of the estimated prices. Now one thing to note is that this is actually telling us, right, this 9.0 is actually this beta 1, right? It's telling us that if you increase the room number by 1 unit, then the price would increase by 9 units. So that is what this is actually trying to tell us. That is the understanding we need to have. Now also, trusting our coefficients, you can see that the p-value is 0.00. So we can actually trust. Remember we said we needed a threshold to assess the accuracy, and now we said the threshold we'll be setting is 0.1, and look at this, we have 0.0 here. So like we can actually trust that what we built is actually acceptable. So that is that about that. And finally, the other way, we'll wrap up in I think 10 minutes. Thank you for your time so far. So finally, the next way to run a simple linear model is to use the common place method, which is using sklearn. So if you want to use sklearn, so let me just say method 2, and so if you want to achieve the same result with sklearn, so what you want to do is say from sklearn. So sklearn is a Python library for machine learning. It has a lot of functions. It has a whole lot of functions. So you want to say from sklearn.linear model. From sklearn.linear model, you want to import linear regression. So you run this. So once you run this, what you want to do is to declare your independent and dependent variable. So your dependent variable here is our y. So our y is data frame with the prices. So we say data frame and price. So this is our y. So now our x, right? We want to say what's our x? Our x is the data frame, and we are using the room number, right? So now I'm using double colon because it has to be a 2D array. So that is the reason I'm using the double colon. So now you won't say room num. I just want to be sure I got that correctly. Let me just copy this here. So that is our x. So now you want to run this as well. So now we've declared our y. We've declared our dependent and independent variable. So now what you want to do next is to create an object of the model. So we want to say our linear model again. So we said lm. So let's say lm2. This is our second linear model. So lm2 is just basically you call this linear model, right? So you just say linear regression and you give it you close the brackets. So we've created an object of that linear model. So the next thing to do is to fit that model. So now you just say lm2. So lm2 dots. Now you want to fit it. Now you give it our x and y to train with. So you say x, comma y, and that is all. So we built our linear model. So now what you want to do now. So the advantage this start model has is that start model basically gives you a summary, but you cannot get all of this summary. You can't get all of this summary with you can't get the summary with the sklearn. So what you want to do is to just get the intercept and the coefficients. So you can say lm2 dot intercept. So now you see the intercept is minus 34, and if you compare it to what this gave us, it gives us something similar, even the same thing. So what you want to do is to also get the coefficient, right? So you want to say lm2 dot coefficient. So now once you do this and you run this, it gives you the coefficient as 9.099. So this is also what this gave us. So basically that is how you run your linear model. So if you increase the room number by 1 unit, the price would increase by 9 units. So that is how to interpret this model. And we've come to an end. But before we close, let us just do one more thing. Let us just plot. So we just see what we have. So let's say plotting. So we just want to plot our independent variable and our dependent variable. So what you want to do, we've been using so far is SNS.joinPlot. So now you want to call your x. What is your x? Our x is our data frame with the room number, and our y. Our y is the data frame column of the price. So you say price, and finally we have to give it our data, the data we are working with. Our data is equals to data frame. So now if you run this, this is what it looks like. You can see this is looking positive correlated, but we want to include the regression line, right? We want to include the regression line, so we need just one more line of code. So the line of code we'll use is kind, and kind will be equals to regression. You just give it reg. So if you include this line, if you include this kind, normally it just gives you, it just draw the line of best fit, which is what we're trying to talk here to talk about here. That's the line of best fit. And where is it? Okay, something like this. It just draws this line for us. So now if I run this line of code again, um, it will run, and now you can see the line of best fit for this particular data set. So that's about our machine learning class. So let's just name this ML class. So I would share this script with you if you need it for any review or something. So I'll just share this notebook with you. So that will be the end of our machine learning class. If you have questions, I think it would be now would be a very like great time to ask questions if you have questions. Do you have questions? Yes, yes. We can get the data frame for practice. We can get the data frame for practice. All right. So if there are no further questions, I would like to appreciate you all for your time. And before you leave the meeting, I would really also appreciate it if you follow us on our YouTube channel. So I'll paste some links, and I'll paste some links to us. So the first link is the link to our YouTube channel. Would appreciate it if you follow us. You can go through our YouTube and go through our videos and all of that. Um, um, Esther, I'm not sure I understand your question. You can just um, clarify your question. Yeah, thank you, Favor. So one more thing, would I also appreciate it if you follow us on our Twitter. All right, so I'll paste our Twitter link as well. Would appreciate it if you like give us a follow on our Twitter, Instagram, Facebook, YouTube. We are actually everywhere on social media, so would really do appreciate it if you follow us. So this is our Twitter, and if you want to follow me as well, my personal Twitter account is David. So basically, I post about machine learning, remote sensing, and GIS with Python. So those are like what I basically discuss about. So I would appreciate it if you give me a follow as well. Yeah, I shared additional Timothy. I shared additional resources earlier, and okay, I'll just copy and paste them again. So I shared additional. Probably you've not joined the class then. So these are like the links to additional resources I shared earlier. So if you want to like read more or do more things with machine learning, you could also go through all of these links. So I've sent the links as well. So these are like links for additional resources. I think I shared more even earlier. Let me just see. For simple linear regression, I found some stuff like pretty cool online just for some resources. Okay, I think this is it. So these are like just use cases like how people have used machine learning in the past. You could just look at this. So what we did was looking at how price would change, looking at how you increase or decrease the numbers of room in a building. So um, that is those are all of the additional resources for this particular class. So if you need to reach out to me, let me just leave my email. Maybe you need to ask questions or something. I'll leave my email.